here.
Is that for the inkjet printer?
Yeah.
Okay.
Yeah. And so then you have a capacitor, which will create a field, electric field. And right there you have the paper. And so this here is the little thing. Oh yeah. From here to here is approximately 5 millimeters. This one as well. This is called the gutter. Now this is important because what happens is the droplet gun, you drop a lot of ink, and some of that ink it's not necessary to land on the paper. So what the electron gun here will do is it'll blast electrons at an ink droplet going that way. So it's blasting them at the ink, and that gives the drop, which has a radius of approximately 84 microns, like micrometers.
Yeah.
Micrometers. And the droplet gun shoots the ink at a velocity of 20 meters per second. And now the droplet gun has the ink travels from here to the paper in approximately 3.5 I think that's, I don't know.
10 to the minus 6?
Yeah, 10 to the minus 6 microseconds. And this is how much time the gun has to charge the ink droplet in order to give it a negative charge. Oh yeah, because right here, here's positive and here's negative. It charges the droplet, it'll make it negative. Now, the gun must give the ink a charge of approximately 1.9 times 10 to the negative 9 coulombs to allow the capacitor to deflect the ink drop into the gutter. So when it's passing through here, it gets repelled by the negative side over here.
Mm-hmm.
And then instead of going straight like that, it would do this and deflect into the gutter right here.
Mm-hmm.
So what it tries to do, it gives it a charge, and it comes out to be approximately 54 micro amps. That's how much the electron gun here gives the ink droplet. Now the reason, right here, it tries to make a 45-degree angle so that the distance traveled this way equals the distance traveled this way. That makes sense? And it does that. Now, it creates a uniform, this right here creates a uniform electric field which allows only the neutral drops to fall. Others are deflected towards the gutter. But how strong does the field have to be? Now, the mass of the droplet equals 1.3 times 10 to the negative 10 kilograms. And the charge on the droplet, as you saw, is right here, is 1.9 times 10 to the negative 9 coulombs. And the velocity of the droplet is 20 meters per second. So what has to happen is this. If it leaves ink, right here, the capacitor will travel it leaves at a capacitor at a 45-degree angle. And it moves 0.5 millimeters that way and down. Then, so it has to be, all right, so we have the time that it takes to travel that distance is delta t, which is, what is that? It travels 5 millimeters in 20 meters per second, which will be 2.5 times 10 to the negative 5 seconds. and that's how much time it has to travel through the capacitor field, I mean the electric field in the capacitor. And so now the current, the current inside of the field, it has to have the current is volts per second, and that will be the velocity.
The current should be charged per second, but that's okay.
Yeah, charge. Right, charge per second. And it comes out to be, where did I put that? A y delta y. See, 20 meters per second at 2.5 seconds, so it's 8 times 10 to the 5 meters per second. That's the acceleration of the ink droplet. And so, okay, what I get is that you get Q times E, right? We learned that 2 days ago, and equals mass times acceleration. Now, the reason I was saying is that the ink droplet is going forward only, right? And so, at that time, it's not going downward at all. So its velocity is 0. So it has to accelerate downward so that it reaches 20 meters per second as well as 20 meters per second that way. So it accelerates at 8 times 10 to the 5 meters per second squared. And that's important because that gives you the energy of the electric field. And you get E equals MA divided by Q, and you get the mass of
Do you have in there an explanation of how does the printer know how to make an A and a B? What makes an A and a B and a C? How does the ink vary to make us an A, for example?
Oh, like the letter A?
Yes?
Actually,
I mean, there has to be something in that electric field that varies, that actually distributes the little black droplets, the ink droplets,
right.
that says deposit them in such a way that you make an A, or the next time you make a B.
No, actually, I didn't find that. I
Okay.
just found out how the capacity and stuff works.
Okay.
And
It's in your capacitance. The deflection field that you call in your capacitance.
yeah.
It's the variation or the opposition of the electron, the ink droplets that go through.
Yeah, oh,
That
yeah.
causes the A and the angle at which the drop.
So I would figure it would charge the ink droplet different charges so that it gets a different angle, right?
The charge is the same,
The
but
charge-
it's the electric force or the, I don't know if you, what would you call it,
Field?
yeah, it's the field that attracts or opposes the electron, which
Right.
causes the angle when it's shot through the deflection field.
Right.
That's what causes the angle of the droplet. So when the paper goes by, it either puts it straight on, or it angles it, puts it up or down, or. That's what you're asking, correct?
Yeah, it is. It's really the variation in the electric field, because you put your paper and the machine reads your paper, the computer
Right.
basically knows right now, if you're using a printer, the computer knows what you want to print.
Right.
So this information is relayed to the printer, and the strength of the field, the variation in the strength of the field basically sprays the black dots in the right spots to generate A, B, C, D, etc.
Oh, it sprays them?
That's right. It is, that's what you show. You have over there, the ink cartridge, and then you have the electron gun sprays the charges. That charges the ink, basically. The ink droplets get charged. As they pass through that electric field region that you show, which you call the capacitor,
Right.
okay? As they pass through, now there is a force exerted on them, and there is an electric force.
Right.
And so that electric force can be modulated, can be varied,
Mm-hmm.
okay? And so that electric field can move that dots, those ink dots, up and down, left and right, and then it allows them to form the actual or the various letters.
Yeah. Right. And another interesting thing I found is that in here, it's approximately 480 volts.
Now what?
480 volts.
400, okay.
In the electric field, so don't touch it.
Thanks very much.
No problem.
All right. I need somebody next time to talk about atmospheric electricity. How about that? This may be even more interesting.